Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on embedded systems. Today we are mainly discussing about on inside the computer. First one is the important terminology. The unit of data size bit, a binary digit that can have the value 0 or 1. Byte 8 bits, nibble half a byte or 4 bits, word 2 bytes or 16 bits. The terms used to describe amount of memory in IBM PCs and compatibles. Kilobyte capital K 2 power 10 bytes, megabyte capital M 2 power 20 bytes, gigabyte capital G 2 power 30 bytes, terabyte capital T 2 power 40 bytes. Mainly, we need to remember these terminologies in case of any computer. The CPU is connected to memory and I/O through strips of wire called a bus. Here, CPU or processor is connected to memories, RAM or ROM, and also I/O devices, printer, disk, monitor, keyboard. These are the I/O devices are connected through a bus. Okay, here carries information from place to place. We are using address bus, data bus, and control bus. We'll discuss one by one here. Address bus is a unidirectional. If you see the arrow, it is showing only the one direction. If you want to identify any hardware device or a particular memory location, we are using this address bus mainly. Okay, here for example, if I have the only the address bus, I have only the 8-bit addressing, so that my addressing range 8 zeros to 8 ones, so that my 8 zeros my binary I am representing with x here 0x00, 8 ones I represented with hex here 0xff. This is my addressing range. 2 power 8 means 256. This my locations are 256. This is a way we can identify how many locations between this range. Okay, 256 locations, and each location I am storing 1 byte in our CPU. That's why 256 bytes. For example, if we have our 8-bit addressing, we can store up to 256 bytes. For example, let us take another example. We have 16-bit addressing. We have 16-bit address bus. We can access up to 16 zeros I represented with X format 0x 4 zeros. 16 ones I represented with X format 0xff. This is my addressing range for the 16 bit. 2 power 16, this is my memory I can access by using this address. 2 power 16 means 64 kilobytes. Here, as we discussed initially, 2 power 10 means 1 KB, and 2 power 11 means 2 KB, 2 power 12 means 4 KB, 2 power 13 means 8 KB, 2 power 14 means 16 KB, 2 power 15 means 32 KB, 2 power 16 means 64 KB. Here 2 power address lines equal to that much memory we can access. 2 power 15, these my 15 address lines we can access up to 32 kilobytes. Here, based on our address lines, we can access that much memory. For example, if we have 30 address lines, we can access up to 1 GB. Okay, mainly by the use of address bus, we can access, we can identify the particular hardware or a particular memory locations. And the data bus is a bidirectional one. Okay, if I want to read the data from the memory or write the data to the memory, we are using this data bus. Data bus is a bidirectional. If you see the RAM, it is a read or write access memory. Okay, it is both read or write. That's why I'm giving the both the directions. ROM, it is only the read only memory, so that I'm giving only one direction. Printer, it is the output device, I'm giving the out arrow. And disk is a read or write. I can read the data from disk and also write the data to the disk. I'm giving the both the directions. Monitor is the output device, I'm giving the out arrow. Keyboard is the input device, I'm giving the input arrow. And this is my data bus. Okay, here the mainly our processing speed we are mentioning using the data bus. For example, here we have the 8-bit data bus. Our CPU is 8-bit CPU. For example, 16-bit data bus, my CPU is 16-bit. For example, 32-bit data bus, I have 32-bit CPU. Okay, mainly our processing speed mainly based on our data bus. Okay, here the mainly here data bus, for example, this is a RAM, random access memory. It is a temporary memory. Whenever the power is off, completely this memory will be erased. Read only memory or program memory. Okay, whenever the power is off, still our data is retained. Okay, this is a printer. These are the I/O devices. Okay, mainly data bus used to read or write the data from the memories. Okay, control bus. If I want to specify whether I want to read or write the data from the memory, we need this control signal. Okay, for example, let us take, I have one memory location. Let us take 0x01. For example, this memory location data I want to read, so that the first I need to locate the address with 01. By using the address bus, I want to identify the location with 0x01. Okay, I'm able to identify the address by using the address bus. So that after that, I want to read the data or write the data by using the control. For example, I want to read the data from this location, so that the control I can give the indication to read. By using data bus, I can read the data from this memory. Okay, similar way, I want to write the data to the same location. By using address bus, I can identify the location. I'm using the control bus to give the read signal. Okay, give the right signal. Right now I'm writing the data to the memory, so that I'm giving the right signal to the this control bus. By using data bus, I can write the data. Okay, these are mainly we are using these three buses. If I want to read the data or write the data to the particular location, we need these three buses. Okay, mainly this is our mainly CPU inside our computer. Okay, next our inside the CPU we have our ALU. This is one of the logical circuitry. If you want to perform arithmetic and logical operations, we need this ALU, arithmetic logical circuitry. Okay, it will perform arithmetic and logical operations. Arithmetic means addition, subtraction, multiplication and division, and logical operations means undo or not. Okay, if you want to perform these operations, we need a few registers. Okay, we are using these registers to perform the operations. And here program counter, if I want to fetch any address, for example next instruction to be executed, if I want to find out the address to the next instruction to be executed, we are using the program counter. Okay, it will always increment +1. For example, if it is 8-bit controller, my program counter increment by 1. If it is my 16-bit controller, my if my processor is 16-bit, my program counter increment by 2. If my 32-bit, it will increment by 4. Why? Because each memory locations we are storing it only 1 bit. Okay, that's why here program counter always fetches the next instruction to be executed. Okay, this is a program counter, use of the program counter. Next one, instruction register, instruction decoder, timing and controller. Okay, these are the mainly used to decode the instruction. For example, we have the some assembly instructions. If you want to decode and give to the piece of code to the ALU, we are using this instruction decoders. Okay, mainly if you want to decode any instructions, we are using these registers. And mainly this is a use of the instruction decoders. Okay, it is a mainly it is also one of the logic circuitry. It is used to decode the instructions. Okay, mainly these are the registers to perform the ALU operations. We are using these registers. Program counter to fetch the next instruction to be executed. Okay, this is the inside the CPU we want to discuss about. Yeah, thank you friends, thank you for watching.